Let's talk about something that could change, well, almost everything. We're going to dig into how one of the oldest and simplest organisms on our planet might just hold the key to our most complex modern problems. Can the root system of a mushroom really replace plastic, leather, and even concrete? Let's find out.
So to really get why we need a solution like this, you have to understand the scale of the problem. And it starts with a number, 300 million tons. That's how much plastic we produce globally every single year. It's a mind-boggling amount of stuff, and frankly, our planet is choking on it.
And you might think, well, what about recycling? We all do our part, right? We sort our plastics, put out the bin. But here's the hard truth. Less than 10% of all that plastic actually gets recycled. The rest? It just piles up in landfills and floods our oceans. The system, as it is broken. It just can't keep up.
Which leads to a really interesting thought. What if we've been looking at this whole thing backwards? What if the answer isn't some new, complex material we have to manufacture in a factory, but something we could just grow?
And that's where the hero of our story comes in, mycelium. Now, this isn't the mushroom you might see popping up out of the ground. No, this is the incredible, hidden network that lives just underneath the surface.
So what is it exactly? Mycelium is basically the root system of fungi. But instead of just roots, think of it like a massive underground web of tiny threads. And as these threads grow, they act like a living, self-assembling superglue, binding together whatever they grow through into a solid mass. It's nature's own composite material.
And the best part? The process to make things with it is almost stupidly simple. Seriously, you take some agricultural waste, stuff like sawdust or hemp fibers, and you mix in the mycelium. You pack it into any mold you want, then you just leave it in the dark for about a week. The mycelium does all the work, growing and binding everything together. Then, a quick trip to the oven stops the growth, and that's it. You've literally grown a solid object.
Okay, so this sounds cool in theory, but where is this actually being used in the real world? Well, its first major takedown target was one of our most hated materials, styrofoam packaging.
And the difference here is just staggering. You have a material that is literally grown from garbage, from farm waste. And when you're done with it, it doesn't just sit there. It fully biodegrades and turns back into soil in about 45 days. Compare that to styrofoam, which will still be sitting in that same landfill 500 years from now.
When you put them head to head, it's not even a contest. Mycelium foam comes from farm waste. Styrofoam comes from petroleum. One becomes compost in weeks. The other becomes pollution for centuries. And here's the kicker. Making it uses just 1/10 of the energy and releases only 1/8 of the greenhouse gases. It's a total win-win-win.
But look, replacing packaging is huge. But if you think that's all this stuff can do, you're in for a shock. The potential here goes way beyond just a smarter box. We're talking about disrupting industries you'd never even imagine. Yep. By growing the mycelium in flat sheets and then treating it, you can create a material that is strong, flexible, and feels just like animal leather. No cows required. And believe it or not, yes, that same fiber structure can be tailored to mimic the texture of meat, leading to things like a plant-based bacon that actually sizzles and crisps up in the pan. Now this is where it gets really wild. By tweaking the growth process, mycelium can be turned into fire-resistant insulation, sound-dampening acoustic panels, and even load-bearing bricks. We're talking about growing our actual buildings.
And I want to be clear, this isn't some pie-in-the-sky fantasy. It is happening right now. Huge fashion brands like Calvin Klein are using mycelium leather. My Bacon is already in over 1,000 stores. We're seeing everything from surfboards to biodegradable coffins to wall panels being grown as we speak. The versatility is just off the charts.
But of course, let's ground ourselves for a second. With any technology this revolutionary, it's easy to get carried away by the hype. Mycelium has incredible promise, for sure, but it isn't a magic bullet. There are still some real-world hurdles to overcome. Okay, so let's look at the trade-offs. The pros are amazing. It's totally non-toxic, naturally fire-retardant, and it completely composts. But on the flip side, it's not as strong as concrete. At least, not yet. Its lifespan is shorter, maybe 20 to 30 years, and you have to protect it from long-term moisture. But you know, maybe the biggest hurdle of all, plastic is still just incredibly dirt cheap. But even with those challenges, the momentum behind this is undeniable. And the vision for what we can do with mycelium is expanding. Not just from solving problems here on Earth, but maybe even building habitats on other planets. I mean, just look at the timeline. This technology basically started in 2006. By 2011, a massive company like Dell was using it for packaging. A decade after that, it's being sold as food.
Next year, a huge housing complex is opening with mycelium insulation. And for the future, well, NASA is seriously looking into how they could send dormant mycelium to Mars, just add water, and literally grow a habitat. It's incredible.
And that construction piece is so important to come back to. The construction industry is responsible for a whopping 8% of global CO2 emissions, mostly from making concrete. The idea of swapping a material that spews carbon into the air with one that literally grows and stores carbon, well, that's one of the biggest opportunities we have in the fight against climate change.
And the innovation just keeps accelerating. Beyond NASA's work on Mars habitats, scientists are creating living mycelium sensors for robots. It's all pointing toward the ultimate goal, a truly circular economy, a world where our materials don't just get used and thrown away, but are regenerative. They return to the Earth to enrich it, fueling the next cycle of growth.
So I'll just leave you with this final thought. For all of human history, we've gotten really good at growing our food. This technology poses a profound new question. What does our world look like when we finally learn how to grow everything else?